In exercises 5 and 7 assignment, you're looking at simple and differential stains. So you did a lab with simple stains, and you also did a lab with differential stains. And you're going to be combining the knowledge that you gained in those two labs in this one assignment. You're going to demonstrate your knowledge of bacterial shapes, morphologies, and their physical structures, such as spores or flagella, and apply your knowledge of the chemical properties of staining. There's a table that you're going to complete for this lab, and before you begin, you want to review your results from exercises 5 and 7 to determine the special features that the organisms have. Look back in exercise 5 on the simple stains and exercise 7, especially because exercise 7 shows you some of the special structures such as flagella or spores. You were able to see these organisms in lab or their very close relatives. So you don't want to spend a lot of time researching information on the internet for this. You want to think. You do want to research the gram reaction of the organisms you didn't stain with the gram stain, because you will have to put that here. And you also may want to check if they have flagella or if they have a capsule. One thing to remember is you saw all of these organisms except Treponema pallidum. Treponema pallidum is the organism that causes syphilis. I've talked several times about Treponema pallidum, but you can easily find information on this organism in your textbook. Remember that not all organisms will accept a basic stain. Many of the stains that you used in lab were basic stains and depended upon a negative charge to the bacterial cell to accept that basic dye. Think about, as you look at each of these stains, which is a basic dye and which uses an acidic dye. Now you're going to draw a microscopic view of each organism as it would appear in the stain. Let's think about each of these stains. Methylene blue is a simple stain. Any organism that's capable of accepting a basic dye will stain blue. The morphology of the organism, whether it's a rod or a coccus or a sporulum, is going to be evident, and the arrangement is also going to be evident. You may see diplobacilli, bacilli in palisades, perhaps diplococci, or streptococci. That's the arrangement. Now, special structures such as flagella or spores would not be evident in the methylene blue simple stain. And just like its name, methylene blue simple stain is blue. Nigrosin is going to provide a negative stain because, just like a photographic negative, the background is black. The dye is left on the slide and the organism shines through like the moon in the dark sky at night. The dye of nigrosin is black. All organisms can be seen in a negative stain. Why do you think this is so? Next is Anthony's capsule stain. Anthony's capsule stain involved crystal violet and a copper sulfate rinse. The copper sulfate was allowed to stay on the slide. The capsule stain, therefore, is a type of negative stain. The organism itself is stained with crystal violet if it can accept a basic dye. Because crystal violet is purple, an organism that can accept a basic dye will appear purple. The background stains dark pink, and often it's sort of chunky and lumpy looking because of the copper sulfate. If the organism has a capsule, the capsule is not going to accept the basic dye of purple, and nor will it allow the copper sulfate to penetrate, and so it will appear as a clear area around the organism. The gram stain, the most important differential stain in microbiology, is going to classify organisms as gram-positive or gram-negative. However, just because an organism is said to have a gram-negative cell wall, it may not stain in the gram stain. And a very good example would be spirochetes. Spirochetes are incapable of accepting basic dyes. If an organism cannot accept a basic dye, even if it has a gram-negative cell wall structure, it will not stain in the gram stain. And this is often confusing. But if the organism can pick up a basic dye, gram-positive organisms will stain purple with crystal violet. Gram-negative organisms will lose that purple color in the alcohol rinse and will pick up the counter stain, which is safranin. Safranin is a pink color. It's important to remember that both the primary stain and the counter stain is a basic dye. Therefore, if an organism cannot accept a basic dye, it will not stain in the gram stain. The Schaeffer-Fulton Spore Stain allows us to see the presence of an endospore within a bacterium. The vegetative cell, or the cell that would house the spore, if the organism makes a spore, or the organism, even if it doesn't make a spore and can accept a basic dye, will stain pink with safranin. Endospores are going to be stained with malachite green. Remember, there are very few genera which are spore positive, endospore positive. Bacillus and Clostridium are two very important genera that are spore producers. The acid-fast stain, recall that one from lab, where you steamed in the carbofuchsin into the acid-fast waxy coating, the mycolic acid coating of the acid-fast positive organism. Acid-fast positive organisms include Nocardia and Mycobacterium. Those are the only two genera that are acid-fast positive. They have that waxy outer coating made of mycolic acids, and you either have to have steam or detergent to drive that carbofuchsin, which is nonpolar, into that waxy coating. Carbofuchsin is a beautiful purplish red color, magenta. Acid-fast negative organisms are going to stain with a counter stain, methylene blue. Now don't forget that methylene blue is a basic dye. If the organism will not accept a basic dye, it won't stain in the acid-fast stain if it is not acid-fast positive. Lastly was the flagella stain. You got to see a slide, a prepared slide of the flagella stain, although you didn't get to prepare the slide yourself. It was explained to you that the stain coats the organism. It's very much like a hair product, a gel that would coat your hair and make your hair stand up straight. So this stain is going to coat the organism as well as any flagella the organism may have, and the color is sort of a reddish brown. So let's take a look at what your table might look like when you are done. Here I give you an example of Escherichia coli. Escherichia coli is not one of the organisms that you are looking at, but this is how E. coli would look in each of these stains. Now, I'm not saying I would actually do any of these stains on Escherichia coli, but I would like you to apply your knowledge here and think about what would it look like if I did this stain. First, remember the methylene blue simple stain. That's going to show us the morphology and the arrangement. Escherichia coli is a rod-shaped microorganism, and you can see that it has no specific arrangement. It's not arranged in palisades, it's not arranged in diplobacilli or streptobacilli. The organisms are just hanging around there like pickup sticks or strands of spaghetti that you may have dropped on the table. Methylene blue is blue. Escherichia coli is capable of accepting a basic dye, and so Escherichia coli stains blue. Nigrosin is black. Remember that it stains the background and the organism shines through like the moon in the sky. Anthony's capsule stain is going to give us this pinkish red in the background, and the organism, in this case E. coli, stains with the crystal violet. Crystal violet is a basic dye. E. coli is a gram-negative organism. Gram-negative is pink, gram-positive is purple. E. coli has no spores. Safranin is the stain used in the spore stain in order to stain the vegetative cells, and so you see that E. coli would stain pink here, but you wouldn't see any endospores. Escherichia coli is acid-fast negative. It also can accept basic dyes. The counter stain in the acid-fast stain is methylene blue. So this organism will stain blue in the acid-fast stain. And finally, in the flagella stain, you can see that Escherichia coli has paratrichous flagella. The flagella are completely surrounding the organism, and so that's drawn here. A few things to remember. You want to draw these organisms large enough so the morphology, arrangement, and special structures can be seen. You don't want to draw only one or two in each of these boxes, but draw a representative sample. And remember exercise 1 assignment. Draw the organisms relative to one another in size. You can recall that a rod-shaped organism, a bacillus such as Escherichia coli, is much larger than Streptococcus pyogenes, for example. Streptococcus is a coccus-shaped organism in chains, and that organism is much smaller than Escherichia coli. Good luck, and if you have any questions, please contact me.